Good evening, guys. Happy Diwali, everyone. And yeah, good. We are here. Okay, let's start without taking much more time. Welcome to the 34th meetup here for K8SUG, Singapore. Our mission is to increase the Kubernetes adoption everywhere, and that's why we're meeting here. And our main focus is on learning and sharing best practices related to Kubernetes. This meetup is in multiple countries. We started in Singapore, Australia, Canada, UK, and in Philippines, India, and also in Sri Lanka now. We have more than 20,000 members in LinkedIn groups. There are around 8 groups related to it, and now we are in 7 countries, as I've told you. Thank you so much for our main sponsors. Thank you so much, CodeCloud, AWS, Orkes, and SuSe for supporting this particular meetup. These are our main organizing members, Yong Sheng Tan, Fazir, and Ritesh. And these are our organizers and volunteers, Ramalingam, Srinivas, Fatima, Jignesh, and me, Alok. These are today's topic. First, Manju will start with the topic service mesh communication between the clusters. Then I will have another topic from Hak Beng, DevOps Dream Come True Rancher Prime 3.1 with integrated observability and extended lifecycle. And the third topic will be from Yong Tan, Orchestrating Beyond Infrastructure. Thank you so much for our speakers. Let's start with the first topic. Manju, may I call you on stage to share your topic? Thank you.
Hey, am I audible? Yeah. Hey, Manju here, and I'm going to talk about service mesh. We will talk about. I do a lot of consulting with all the K8s. I'm working with K8s for about 10 years now, right from the start when it started up. All right. So here I'm going to talk about service mesh. Just a show of hands, how many of you use service mesh in any extent? Okay, a lot less people out. So I'll try to be going more detail out because I've had more and then I could have skipped over some topics. So I'll try to go more. So what is service mesh? I think let's understand this, right? Service mesh is basically a kind of security measure. It's an infrastructure layer, and that's what we're going to talk about. So basically, it's an infrastructure layer which connects various which connects all the microservices together, right? And the closest definition of service mesh that you have is that you have it basically based on 3 broad principles: the security, observability, and reliability. Also called as traffic management, and we'll come to see what is that about, right? But you might just ask, right? Step back. I mean, a lot of people don't know about service mesh, right? And why am I talking about service mesh when Kubernetes in some form already does this, right? And might have wondered, right? Security already have in Kubernetes. You have a security, you have observability, you have a lot of Prometheus and all that. You can get it. And traffic management, if you have some ingress or reverse proxy, you can actually get it already. What is so special about service mesh? And I think this is what gonna talk about. Let's talk about one by one. That's security. So idea is what's problems does this solve? The thing that you can see in my screen is that Kubernetes by itself is kind of secure from outside, right? Within the cluster, you have all the machines connecting together. You have to have a service account. You have to have without the service mesh, one pod can talk to each other, right? But when it goes to this level, after you have this one out, each proxy can only all the pods which are meshed can only talk to each other through these proxies. So this proxy will only talk with this mutual TLS, which means that there'll be certificate shared out. If a pod which is not having this not meshed, right, it cannot talk to the other one because it doesn't have the MTLS. It needs to define the MTLS. So that's how you get the security. Now you can define policies on your Kubernetes in this your deployment level, where you can define that you can have, right. This is how you're solving your security. Let's go to the observability part, right? This becomes quite obvious, right? Because proxy now takes over all the networking, all the data that is collected. This proxy has been written to ensure that all the data can be exposed out. Because it is taking all the connections out, how many connections it's got, from where it has got the connection out, has it denied any connections, does it need to do any retries and all that? all this data is already there. So that's why it helps in observability, because now your container, and let me go back to this thing. Now your container is not responsible for taking the data. It's a proxy which is responsible for gathering all the metrics, and it can give you that. That's why it helps in the observability out. Reliability is, again, because it's proxy that can talk to each other, all the networking part, you can configure this proxy, and not by writing any code, just by configuring the proxy, you can talk that one pod can talk to other pod. Let's say there's a connection, there's a failure. You can just retry. You can define how many retries that's possible. I like to show that in demo. It's just that just before coming to this, there's some problems on my pods out. So I'll try to see if we can still connect it. But this is what is. You can retry mechanism out. An application developer doesn't have to write the container logic into it. You just need to configure it. Okay. So these are the very high level. How does it solve the observability, security, observability, and reliability concerns, right? And let's look at what features provided by service mesh. So this is a top list of features, but this is not the end of it. And each service mesh provider or a vendor provides have their own list of activities or list of features that they have. Automatic MTLS was already talked about, and MTLS stands for mutual TLS, which means that it is not dependent on your root certificate from some other organization. You can sign certificate to two clusters, can sign certificate each other and have them connecting to it. So mutual TLS is automatically generated by this controller component that we talked about, or identity component that we talked about earlier, right? Retries, we just talked about it. And we can also have the circuit breakers. Let's say a service which is not reachable, right? You don't want to keep on trying, because that's effect. Either you fail over or you just time out. You at least tell the client that, okay, you know what, it's times out. And this timeout feature, you can put that in your observability pattern to recognize, to see the problem, why it is getting timed out, right? So those kind of data can help you. The whole reason of getting observability is all about how can you improve your application. If your application is timing out, if your application is retrying often, you can get those data, right? Without writing a single code in your container. A load balancing, you can have two services together and load balances out. We'll actually look at it in the demo if we can, right? Telemetry monitoring, we just talked about all these features. Because of this proxy thing, you can get all these features out, right? Traffic permission, you can have two namespaces only talk to each other. You can actually get, let's say there are three namespaces out, only two are meshed, or all three are meshed out. You can talk namespace A can only talk to namespace B. Because the proxy has the details out, it will recognize it because all the traffic goes to it. You can write those permissions. Now, suddenly, right from, let me go back before, right from direct pod integration, where you do not have any control out, with this proxy, you can define between, okay, this pod can only talk to this pod, or this pod can only talk to this pod. This is what the beauty of service mesh, because this proxy does the networking part of it. Right? And the last, my favorite, and this is a core topic that I wanted to cover up in this particular one, is multi-cluster. So all we talked about is within the cluster, right? All talking to each other. But two different clusters, how do you really communicate? Because remember, if you want to talk, one cluster needs to talk to another cluster out, you need to open up a proxy. You should have an ingress in one cluster and you can make an API call. But that's not very efficient. That's also a security loophole, right? Because you're going outside the cluster out. If something happens out, there's a middleman attack and all that, you can control it. What if you can have two clusters connect to each other in a proper way? And well, I'm gonna show you that how my architecture is that. You'll understand from demo what I'm talking about. But this is a big thing in multi-cluster, because I have hosted out about 500 to 1,000 clusters. You can't be calling a public API all the time, and sometimes public API change, because sometimes the AWS you have a node hosted out, you restart your nodes, you get a different IP. You can't be relying on that, right? So if you have a connection within it, it doesn't matter if the public IP changes, you can connect directly internally. So two clusters internally as if they are in a single cluster, right? So that's what we're gonna talk about it. So what about, so a basics of multi-cluster communication is all about certificates, because as we indicated, right? Two clusters, if they, within a cluster, if you, there is a identity component that we talked about, which issues a certificate to each proxy. But two different multi-clusters have to follow a same route. So like any root chain, it's called an trust anchor. any chain of certificate, right? You have a root certificate, you have an intermediate certificate out. What you do is that you can, when you are building your clusters, you start up with this one. When you install the service mesh, you utilize this service chain, so that when this cluster talks to this cluster, or the identity component here and the identity component here shares the same root. Because remember, we talked about automatic MPLS. So one cluster, when it generates a certificate, and it sends to a different cluster, the other cluster has to understand, because if it's not from the same root, it will not recognize it, right? So that's why you have a common root. This is the basics of multi-cluster conversation. You need to have a root certificate distributed out. Now, different vendors do it differently. And I think I'm showing 3 of them and see how 3 different systems does it. So this is the first product called Linkerd. Linkerd is quite famous. There are thousands and thousands of clusters. I have deployed a lot of clusters out. Linkerd is quite famous. It's quite completely open source out, but they do have an enterprise version as well. But your open source is completely free to use. You can actually deploy production ready and all that. It's just that you don't get support, right? And if you have problems in service mesh, this is an advanced topic. You'd rather have a support if you're an enterprise business. But then this is an open source. You can try it right. What I'm showing you today is completely open source, right? So what is the component? It's the same component that we talked about Lydia, but now you have a proper namespace. So when you install Linkerd, you have something called a Linkerd namespace. Now this Linkerd namespace defines your same thing, destination out, where it's basically a kind of controller. You have a proxy injector when it proxies out and init. Everything can be controlled by CLI. CLI, this is not a component. This is like, you can actually go into your SSH directly into the cluster, or the Bastion system, which is managing cluster. You can install this thing, or you can manage the data plane of it. And then all your this one out, whenever this a new pod comes in and it comes with certain this thing out, it injects the Linkerd proxy. Now, the Linkerd proxy is their own proprietary proxy. It's called, it's developed in Rust, which is layer 7, which is the highest layer part of it. And that's why you can control all this permissions on all that. And this is how it connects out, right? And this is the thing that we saw. This proxy, there's a particular pod which has a proxy. It connects to another pod which you need to connect. It needs to talk to a proxy. And this is all MPLS. So no connections, nothing can go unsecured here, right? So this is all open source, and this is Rust is very lightweight. This is proprietary of Linkerd. They have developed, although it's open source, but it's very proprietary of Linkerd, that Rust. So this is your common structure of it. This is what I'm going to show on demo 1. So we'll come back to this diagram a bit, but I'd like to explain what is happening here, right? You have 2 clusters. I have this home cluster, which I'm currently running at home, and there's one at DigitalOcean. We could have used, you can replace that with ADS if nothing matters, or because what I'm using in here is a pure VMs, or a droplets, as we call it in this thing. There's nothing about I'm using a Kubernetes of AWS or a Kubernetes of these. I'm not using any of them, right? So this trust anchor, when I deploy the Linkerd on both the clusters out, it uses a trust anchor, right? And here you can see this is the multi-cluster. This is the component that we talked about. Any service provider, service mesh provider will have their own Linkerd multi-cluster out. And you have this gateway installed out. There are 2 components, gateway and service mirror out, right? And then you have a DBS, this is your normal pod. So the flow happens like this. Let's say you have this, your client connecting to an ingress. Now ingress is a normal ingress, right? I've used traffic here, right? It connects to traffic. It calls this service mesh. It's called this, sorry, the adminer, which is the UI component of it. It calls the pod. It calls a service here, but this service does not exist here. This is just a dummy service, which is actually a service residing on the DigitalOcean, and it through a gateway, it connects up. Now, this is a very specific feature of Linkerd. How does it connect out? The service mirror feature is specific to Linkerd. Every vendor does it different. We'll see that in action in the demo, right? So we'll come back to this when when we're showing the demo out. I'll relook at it. Let me go to the other one. The other one is called Puma. This is also very famous. This is actually developed by, if you all know about Kong, the Kong gateway is quite famous out. This actually developed by NAT. There's an open source again, and there's the same feature out. You have a control plane, you have this data plane, which has this proxy. Nothing different here, just that the structure is basically the same. The only difference is that if you recognize this icon, if anybody can recognize already, it's called NY. NY is again an open source proxy. Now, Service Mesh uses it because it's quite famous, but And this is what Kuma uses. Kuma does not have their own kind of, like Linkerd has their own proxy. This Kuma uses Envoy as a proxy. And as you know, proxy is the main thing in service, right? There's something called the distributed tracing, the Jaeger. We'll show you about it in the demo, right? Now, this is a multi-cluster communication of this thing. If you look at it, similar to it, I'm not sure it's quite visible here, but what do you hear is this ingress component. In Linkerd, you have this gateway. Here you have this something called a zone ingress. Instead of calling a cluster here, or rather, a cluster, they call it a zone, but basically means the same thing. It's just a terminology different. But only thing Kuma has that is Kuma uses something called as they need a cluster for something called as global plane. They have a data plane, you have a control plane, but you also have a global plane. Why does a global plane? Because they don't want you to build up this root certificate. You set up this global plane, and this cluster connects to this global plane. You can connect as many clusters out. So like in Linkerd, you have to actually generate the root certificates and distribute to all the clusters out. In Kuma, you don't have to do that. The moment you connect to this global plane, it specifies the clusters out. That's the only difference. Otherwise, this global plane actually does nothing. It has a UI which manages out, but this global plane is responsible for doing that. So a lot of your control plane part that we shown about has been taken over by this global plane. That's the beauty of it. It becomes easier. Is it better than Linkerd? Probably not. Does it become easier to deploy it? Yes. Then we come to the STO. This is one of the famous one. A lot of people use it, right? Again, the same topic. You have this. It's just this diagram is kind of opposite the way STO shows it. Their control plane is down below. Their controller plane is a pure daemon which runs it called STOD. And you have the same thing. You have a service. You have a proxy. They also use Envoy as a proxy, right? And this is the proxy that we have. Now, you remember you call it a sidecar proxy because if you notice, this proxy is deployed on the same pod. Each other application pod you deploy, you have this proxy there. That's why it's called a sidecar, because it runs alongside your own pod. And that's quite common, right? You can have multiple containers run it and it has a sidecar component. But this proxy runs as a sidecar. But Istio has one more feature that you can run as an ambient one. What is the ambient one? Which means that you don't need to run a proxy here in this container. Let's say you have two nodes. It will be one proxy which is running for a node. So any network which goes outside the node will control it. That's the difference between an ambient and a sidecar proxy. But ambient has this, it's still in beta. It cannot do a multi-cluster communication, or it is still in experimental phase. That's why I'm not taking it here. But the sidecar proxies are quite common across the board out, and that's what I'm going to use. So that's the difference between sidecar proxy and ambient. Linkerd is also trying to do that, but has now shifted it. Kuma is not trying to do that. Kuma is always believing on the Envoy part of it, right? So this is like a shift. Everybody's shifting it because a lot of people do not want their sidecar proxy in this thing, because sometimes people say it is a kind of a issue there. They wanted to have some kind of security because you're injecting certain sidecar. Okay, so okay, this is different types of it. Just in interest of time, I'm just gonna do that. I'm gonna just show up my setup, how we're gonna do that. One is this home setup here, and then one is a DigitalOcean out. I've connected these two systems to Tailscale. Now I could connect on direct internet, but Tailscale is a VPN provider out where it's again an open source. You can connect to each other out. And these are all the VMs that we have. I have this is for the Linkerd. What do you say? Link is the Linkerd. The Kuma is a Kuma one, and the STO one. So I've connected this Cloudflare to connect to this channel out, right? So this one I'm gonna do that. So I'm gonna show that this is what I'm gonna display then in the call. So I'm gonna deploy two containers, which is an adminer app and a Postgres app, right? And in two different clusters. And when I deploy this service mesh, it will automatically create this, what you call is this, there's the same service name, right? But it injects with this DigitalOcean as a link, right, for it. Let's just try that out. If I can get an access. Huh? Huh? Come on. It always happens in demo that. Okay. So this is one cluster which is already running with Linkerd. So what you can see here, we can expand this. So what you see here is that you have this Linkerd component. This is a Linkerd core component out. This is the dashboard component of it, and you have this thing out. So I'm not deployed any deployment here. So I also have a separate one called. So I'm logging to. So I've logged into my DO component. So this is what you have. It happens as internally you have a SSH key of it. So I'm actually connected within from one machine, connected to other one, and I'm gonna deploy. So this is your all this Postgres components out. I wanted to show this out, but internet out, I'll just deploy it directly. Okay, so I'll deploy a. Okay. This is a PV. Because I'm deploying a database, I need a persistent volume. I am deploying the PVC for it. So if you look at that, this one is already bound to the PVC, right? And then I apply a secret for it. It's a very simple secret. And then finally, I apply my actual database. My oh, sorry. So you have this thing already. Let me go back to my original cluster, right? And so run. So I have this URL already prepared. I basically. So this is so if you look at the link here, there's an admin and component, there's a demo link home. So what I'm trying to essentially do is this one. I have deployed this admin in home cluster. So this is your home cluster and that's a link to it. And I'm now trying to connect to. So if you look at it, the way it's already defined. Okay. Okay, somehow it's not getting connected. Time is it? Okay. Can I have 5 more minutes? 5 minutes, huh? Okay. So what I'm gonna do is, so L stands for Linkerd. I'm just typing it, there's an alias there. Okay, I'm talking there. So Linkerd, this is called then multi-cluster MC. Okay, I'm creating a link to this cluster. This is my DigitalOcean. I'm creating a link there. I just have to give cluster name DO. I think it's 2. Yeah. So what I'm trying to do now is I've gone back to the home cluster. I am gonna STP. Where is it? Okay. My keyboard has a problem. Okay. I'm just transferring the thing that I generated on multi-cluster to this original cluster. And what we should happen now, so it should already establish out. So if you look at it earlier, we never had so going back to this one, we never had this PG service here. Now it's created this PG service, where this Postgres is actually connecting to, it's actually is there in the DigitalOcean. This is in home cluster. So all I have to do is that here, when I'm going to my, where is my, yeah. So this is my home. I'm trying to connect to a database which is in DigitalOcean cluster, and it should directly connect. See, it's directly connected. So there is absolutely, in this particular here, there's absolutely no database which is running here. So if you can see, there's actually no database which is running here in the DBS components, right? There's only a service which is matching this. So just a recap on this one. This is what we are trying to connect. This administer service, it actually connected this thing. It calls the service. It actually uses a service mirror to write the service, and it's connecting those. This is how the service mesh really works. Yeah. I wanted to show more demo, but then I think we are gonna run out of time. Yeah, but I hope you're enjoying it. If you want to kind of see more, yeah, I'll be here for some time and do connect it. Thanks. Thanks all. Any okay. Hey, thanks.
Next, we have Manju Brian 2.1 with integration and observability by Hak Beng from SuSe. Thank you. Thank you.
Yeah, that one I just connected. Yes, you can see. Cool.
All right. How's everyone doing?
Good.
All right. I think part of the things that I need to do is to get rid of some swag that we brought. So if you fancy a bit of swag, please raise your hand. Either I'll ask a question, or when there's some questions, please try and answer them. All right. Now, thanks for everyone on a Friday night being here, considering that yesterday was a long weekend. Well, some have taken leave today and it's a long weekend. So, glad to see all of you. Just a bit of a background. Myself, I've been working in the open source arena for quite a few years. I think if you look at the color of my hair, with some of you here, I think majority of you here probably still have black hair. Mine has turned a bit gray, despite the fact that it doesn't show that much, but I was using Linux since the 1990s. And I can see that some of you, you might not know what exactly Linux is in late 1990s. But okay, enough about myself. I'm here to talk about Rancher Prime, right? So how many of you have used Rancher Prime or Rancher for the matter? Patrick, it doesn't count. Oh, cool. There's a couple of you. Now, I think one of the things that you need to understand is that technology tends to be very complicated these days, right? I think if you saw the demo earlier on, right, or the kubectl, this kubectl that tends to, well, quite mind-boggling that you can manage the whole Kubernetes clusters just using one command. And obviously, that shows that there's a lot of more side commands that you need to learn, which I think one of the good things about what Rancher has done, and of course SuSe has done, is to make life a lot easier for people. You literally can manage the whole Kubernetes cluster using a UI, right? A GUI that we have. No, I don't have a demo today, partly also because we've got a couple of products that obviously I don't have the resources to run it. But feel free to reach out to any one of us. We've got a couple of guys here, so reach out to us if you want to see a demo or you want to learn more about it. Now, so what is, oops. Okay, right, so I think one of the first thing I want to talk about is, who has heard about SuSe? Okay, good. See, this is very encouraging, right? Many times when I visit customers like, SuSe, how do you pronounce? It's not showing?
Participants.
Oh.
You can see the other side.
Sorry. Yeah. Okay. Hope everybody can see that. So we are a German company, and we started since 1992. So we are probably 32 years old this year. But I think what is of interest is the last few years, we've acquired Rancher in 2020. 2022 was New Vector, which is a container security product. In 2023, if you look at how open source companies tends to mess around with open source licensing, and I think that's something that's of concern. And since SuSe has been around in an open source world for so many years, we thought that we should partner with some, companies like, CIQ that provided Rocky Linux, and of course also the likes of Oracle, surprisingly, right? And they're the ones who provided Oracle Linux. And we formed this organization called OpenELA. So read more about it. It's really to help ensure that things don't go any worse than it can be. Right? It's quite an interesting play in the market today, only because if you look at how open source licensing, many have tried to move away so that they can make more money. Right? End of the day, it's all dollars and cents. And what we are doing here is to double down to ensure that the community can continue to use the likes of what CentOS was, right? And so that's Rocky Linux, and we have something called Liberty Linux. So it's a consortium. And of course, the exciting one would be Stack State, right, for observability. And it's interesting, we just acquired it not too long ago. And that's part of the reason why I can't really demo anything today, only because, yeah, I'm not trained up on that yet. So I admit I'm not trained up yet. So, but of course, for those who cares about Gartner Magic Quadrant, what you'll find is that at long last, we are finally in the Leaders Quadrant. Last year, we were in the Challengers Quadrant only because the analysts felt that they had a bit of questions about the change of management that we had. And obviously, we've proven them wrong. And this year, we are back in the Leaders Quadrant right now. To those who don't understand what is Magic Quadrant, it's okay. It doesn't really matter that much. It's usually for those who need a kind of a way, right, to find out whether are we in the the good quadrant, or we are outside a good quadrant, which really then doesn't matter at all. So, right. So what is Rancher Prime? Now, you realize that I've got two sky blue boxes, right? The lighter blue one, which says Rancher Prime Manager and Rancher Kubernetes Distribution. Now, Rancher tries to make Kubernetes easy. Like I said, you look at the demo earlier on, you gotta just learn kubectl, everything, this and that. But if I can tell you that using Rancher Prime, right, the manager, we are able to manage the whole Kubernetes cluster without touching kubectl. You can do that. One of the customers challenged us. I wasn't very sure at that point in time, right? But I had a colleague there who was a Kubernetes expert. He was able to show literally everything could be done using the UI. Now, it's obviously a lot more than just a manager for Kubernetes, right? You can see that we have an app catalog, observability, storage, service mesh, right? Which we can use Istio. Pretty much all the things that you see in there. So that's just to set the stage. And then from a products perspective, you can look at the right side. We have Rancher Prime, which is obviously the manager itself. Now, what is important to note is that we are able to manage any Kubernetes or CNCF certified Kubernetes distribution, right? So if you have an existing one, hook up Rancher Prime, right? It's a container, let it run. It will connect into your existing Kubernetes cluster and run it that way. Doesn't change anything. All it really needs, right, is to export the credentials, right, your kubectl file, export it out, and then we are able to manage it. It's as simple as that, right? And then from then, you can do whatever you want. Even if the Rancher Prime Manager goes down, right, your Kubernetes cluster will continue to run. So it's not intrusive at all. And then we have Harvester. Harvester has quite an interesting turn of affairs because we designed it as part of an extension to Rancher Prime or Rancher or Kubernetes to allow you to run container workloads together with virtual machine workloads. And then something happened, right? Just I think was it last year, by the name of Broadcom and VMware. Right? So now a lot of customers are talking to us about this. So it literally allows people to run virtual machines. The technology behind it is just KubeVirt. Right? So those of you who are familiar, right, it's KubeVirt underneath it. We have Longhorn that is integrated with Rancher Prime so that we can have persistent storage. New vector, container security, which is interesting because pretty much this was designed from scratch for containers, right? You see a lot of solutions out there. They do traditional security, right? And then, by the way, we can do container security now. That's generally how they build it. This was built for containers. And what is important to note about that is that we are able to, right, do mandatory access control. So whatever happens within the cluster in the networking layer, we're able to monitor it. We use policies. You set the policy, it learns by itself. Once you set it, it will prevent any activity that runs, be it opening a port, right? Be it communications. If it has not been predefined, it will not be allowed. And this allows one of the best forms of security, right? Because you can imagine if an intrusion comes in, and with Kubernetes, right, it's very complicated to try and find out what goes on inside there. But with the new vector, we are able to then lock it down. That gives us a lot of control, right? And even if there's a zero-day attack, right, it will be controlled. The intrusion will still happen, but the damage cannot be, well, it cannot go beyond that. And then we're also running something called Elemental that allows us to deploy operating systems, right, on a hardware. So think of large scale, right, multi-country wide kind of a deployment. Or if you're from, Indonesia or Philippines, where so many, islands, literally what you're basically doing is allowing the local SIs to put the hardware in, plug the network in, right? Elemental will start installing right, or allow the install of operating system, then, so it's going to be quite easy to deploy each solutions using Elemental. StackState was what we just acquired recently. And the interesting thing, the way that we've been told, and I've seen a very cool demo, right, where it's not just about observability, right? It's the ability to go deep into your cluster to find out what's the problem. So the demo that I saw was literally having a visual pitch, clicking in, zooming into the particular pod, and goes down to the fact that it's able to extract out that pod, at least in the demo, there was an OOM, right, out of memory, and the service keeps restarting. OOM kicks in, services got killed, it restarted, right, and that's why it caused the instability. So it's to the level that you can do troubleshooting. So rather than just observability, it's to the level of troubleshooting the problems. Of course, this is a kind of techie group here. I kind of suspect that the resources that I require is going to be quite high, right? If it can do all these things, right? So, ask me again, maybe in a month's time, and I'll tell you what kind of resources are required. And of course, last but not least, we have OS. And what is interesting about the stack that we have, right? There are only, well, I always call it 2.5 companies in the world today that has that full stack, right? SuSe, because we have the OS all the way up to the Kubernetes layer. Of course, we have our red color competitor. And then there's also an orange color, which I say that's half a company because they have started providing enterprise support, but they're more well-known, right, to be fully open source. So if you look at a secure stack, right, these are only companies that have full control over that whole stack, right? Anything happens with the operating system, we can fix it. We also have a base container image. If there are problems there, we can also fix it, right? So generally, that's the message I give to the customer, right? So now those of you who are using community, you'll see the 2 columns there that says upstream and prime. Now, one of the things I like about how SuSe is handling, all these open source versus commercial, right, is that we do not take away any features. Right? You'll find that a lot of companies today, the enterprise version will have specific things which you don't get with the upstream version, the community version, the open source version, right? We don't take that away. So whatever you get, you will have it with Rancher Prime and the community version. But do take note, right? We try to differentiate it, right? So I'll talk a bit about the enterprise lifecycle, which you can imagine that we are providing up to 5 years of support, right, for Kubernetes. Now that's kind of, I don't know whether there's any other companies that does that in the world today. You can imagine that every 4 months, there'll be a new version from the community side, right? And how difficult it is to support that many versions. This was something that a lot of customers are asking for, and now we have provided it. Secure supply chain. So the product is identical, but surprisingly, some of the certification does not apply if you don't have a subscription. So while it's there, you can use it, but it may not necessarily apply. So that's the secure supply chain, or rather the certifications that we have there. And then there'll be some add-ons, which you can see. Also things like application collection, which also have another section to talk about. Any questions so far? Yes, sir.
How about the observability part? Like the major problem that we are seeing in Kubernetes, like cloud native applications, that like once the traffic enters the ingress gateway, so you don't know like by when the application it will be responsive. So does it have an inbuilt network observability monitoring tools?
Yes.
So that again to track. So when my request comes to the ingress gateway, when it is a pod and when it comes back, like is there any auditing there?
Yeah, and I can do one better for that, right? You can go back in time at a particular timing. If there's a problem, you can see where are the problem areas, right? So basically, it's like a, Elastic or, one of these where they collect a lot of logs. So we collect all this information, which also one of the features allows us to take multiple clusters. As long as you can pull all the logs into a single server, we are able to analyze that. So we provide a lot of information within it. So at the network layer, even at the pods, whatever kind of logs that we can get, we can see where the problem area is. So to the level, yes, we can. Any other questions? Now, so one of the things that Dennis, he's our marketing manager, wanted to do was to purely talk about SAC state. Unfortunately, like I said, our training only comes next month, or actually this month, right? So this is where, if we have a chance to show you the next time round, we can give you much more insight about it. Anyone else? Okay, so let me just continue. So I think like I said, right, just to sum it up, what I like about Rancher, is that we have the full features available. Of course, the caveat would be in terms of the life cycle, in terms of the support, right? So there's a bit of differentiation. If you're running it in a production environment, obviously you will only use the Rancher Prime and not the upstream version. All right. Now, there are customers who are using it, say, for example, for non-production, right? So, their staging environment, whatever, is done there. So now these are some of the new features that we have with Rancher Prime 3.1, trusted delivery, right? SASL, SBOM, Prime Registry. Right? So if you're interested in security, or at least, some regulatory bodies requires you to have an SBOM there, right? So that you know exactly what's going inside there and the version numbers. Be using, to make sure that it's all patched up. It's all ready. The key thing that I really like about this new version, right, is the lifecycle management, where we have LTS, right, the long-term support, prime and core. And I'll go a bit more into details about that. Observability, which I already mentioned. So, we already have Grafana, Prometheus inside the product, but this adds to a different layer, right? One of the message was, just as I just mentioned, was the ability to consolidate all different clusters into a single view, or whatever happens. And then application collection, which is sort of curated, various apps that's available. So, yeah, I'm going to skip this slide. This is the one that I want to go more into details. So here I'm talking about the Rancher Prime Manager, right? So the manager itself, right? So that sits on top of the Kubernetes layer. So here is where we have Kubernetes, 2.9, and you have 2.9, 1.9, 2.9.3, and this happens on a monthly basis, right? Every month there will be a new version that we come up with, and we provide, again, this is for the manager, we provide 18 months of support. So which means that when customers are using it, right, we will support them for 18 months. Now, this is short compared to Linux, right? Linux in the industry today, we are supporting 10 plus 3 years. And we have a product that EOL probably, 3-4 years ago, right? There's still customers paying us to support it today, right? Those are usually in mainframes, and probably the application developers have not, I don't know where they've gone to, but there's no one supporting it anymore, and they have to continue using it. So you can imagine 10 plus 3 years, right? Just go back in time, what were you doing 10 years ago, right? And, you can see how long you're supporting it. But Kubernetes is a different, ball game, right? The technology changes so fast, so we need to be able to catch up with it. And that has always been a very big problem for us. Now, again, here is only at the manager layer. We're not talking about the Kubernetes. It already is a problem. So that's the breakdown, right? Full 6 months, and then we have a maintenance of 12 months for all those obviously critical patches. So in total, 18 months, the customer can hold on to a particular version without upgrading. But what is more important, I'm just going to skip some of these. Yeah, so this is up to 24 months. This is the one that most customers get hit with, right? So Rancher, we built, K3S, right, which is the lightweight version of Kubernetes, and RKE2, it's the newer version which we have collaborated with the US federal government. We have a specific team supporting them called RGS, Venture Government Service. And that's the one that helps build a lot of these features just for the US government. And of course, everyone benefits from this simply because, it's open source. So what's the problem? Now, we are now providing up to 5 years of support, right, for Kubernetes. Of course, it's an additional service, but essentially, you can be using an older version of Kubernetes, right, for a long period of time, up to 5 years, which is painfully long for us. Right? Imagine that if every month there's a new version of Kubernetes coming up, right? How many versions we have to support? So in all, if you look at the top and the bottom, right, where Venture Prime, we have a total of 24 months support. And at the bottom, right, which is up to 5 years. All right, so this is a cool feature, especially for those who manages Kubernetes a lot, right? Can you imagine when you upgrade the Kubernetes? Oh my, I don't know why Google built it, but they never thought of that, right? It's so painful to upgrade. The good news is that with Venture Prime, we're able to upgrade it just by a click of a few buttons to 3 versions that we support at that point in time. How much time it takes? Oh, well, depends on how much time you need, right, to move all the workloads out and it upgrades because it's a container. We're basically just, replacing the container. The whole control plane for the Kubernetes? I don't know, probably like 1-2 minutes or even lesser. It's really just, replacing the container, that's all. All it takes is just to deploy in, right? Replace it, that's it. So it's actually quite fast. I think one of the things that we've done well, right, and this is even before SuSe acquiring Venture, is that everything deploys as a container, right? So literally, if you want to deploy Venture, it takes you probably internally, you probably can do it in one hour, right? But it takes probably half a day for you to learn how to get it working. And if you're keen, check with Dennis, when is the next Venture rodeo that we have? Which is a half-a-day session where we talk about the 101s of Kubernetes, right? And then before going into a hands-on lab, which we will deploy, everyone will get 2 or 3 VMs running on, I think it's an EC2 instance, right? And then you can try it out. And by end of the workshop, you would have already deployed a full Kubernetes cluster with Venture running, right? It's that simple. Okay, let me just move on. Application collection. So one of the things, okay, how many of you are familiar with OpenShift? Okay, almost the same number. Generally, when I talk to customers, yes, we are using OpenShift. Who is Venture, right? That tends to be the thing. But I think the number of hands that shown up are quite similar, so I think I'm quite happy. Obviously, you're a technical group here. Now, if you do a comparison between OpenShift and Venture, right? OpenShift is an all-in-one product that allows you to do, run your whole CI/CD pipeline to run container workloads. It's got a container security called StackRox inside there. It's got a whole bunch of stuff, right? You also have a multi-cluster management. I think what's it called, AMS or something? ACM, right? So thanks for that. And you guys really know your stuff. So it's good for customers who feel that they want everything in one. Whereas if you look at our strategy behind our products, it's always about integrating with different solutions, right? So I don't have a slide here, but one of the typical slides I show would be all the third-party cloud-native applications that we support, right? And it's in true open source fashion, we allow customers to integrate whatever they want, right? So if you like GitLab, by all means go GitLab, right? If you're trying to use something else, by all means. So that ability to integrate different products is where our strength is. And what you get is a simple platform that manages all your Kubernetes cluster. Hybrid, multi-cluster, multi-cloud, right? That's where our strength is. Now then, conversely, for customer who feels that they may not want, right, to get their hands dirty integrating all these solutions, this is why we came up with application collection. We curate it. We make sure that if there are vulnerabilities, we patch it. So you can deploy it via Helm chart. And all you really need to do is just, click to your, the marketplace in our venture and click on the necessary, whatever app that you want to install, and that's it. Okay. I'm just going to quickly move a little bit more since I've lacking of time. Now, just note that these are what we are supporting today. Yes, sir. Harvester. Harvester is an add-on that you can install, and once you add it in, right, you see your VMs in one of the the tabs on the side. So you can, yeah. Thanks for the question. So there's a list of applications that we have, and we're trying to grow it. And this is how it looks like, right? So this is the marketplace, and you can just, these are all based on Helm charts, right? And I'm just going to cover just this last slide. Actually, no. Let me just go into more details about this. So 4 areas of looking at information that you get from our observability or stack state data. We try to make it accessible regardless of how many clusters you have. We put it into a single, pretty much all these log collectors does the same thing, right? Elastic, right? Splunk all does the same thing. So not that innovation or innovative for the matter. Easy navigation, right? Again, this goes back to the same point that I've been, been stating. We make things easy to use, right? We try everything to use it from a UI perspective. So you'll find that for those not so technical people, right, we have already templates that you can use as dashboards to view different aspects of your cluster. Right, and then to bridge the knowledge gap, we have best practices that we can use. Right, so again, it's to help you to identify your problems faster. Sorry, actually, this is the point that I was trying to make. Right, providing diagnosis and remediation very, very quickly. Again, Kubernetes is not easy to troubleshoot, right? Because you saw everything is text-based. So, but with our observability solution, which is based on stack state, we are able to give you that visibility. All right, with that, if there's any questions, feel free. I think my time is up. Thank you so much for your time.
Thank you so much, Mr. Hak, for sharing the insights on Manju Branch 3.1. Next, I invite Yong Tan from Orkes, Orchestrating Beyond Infrastructure.
Okay, cool. Yeah, thanks everyone for being here. Yeah, great that people are actually coming to a meetup on a very busy weekend where most people will be on a holiday across the northern border. So yes, very passionate group of people here. I'm keeping you from going home. So today's talk is going to be pretty quick. It's going to be a bit of a deviation away from your typical Kubernetes talks because I'm talking a bit more of a higher level abstraction away from just infrastructure and more of the topic of orchestration in general. So let's get started. A bit about me. My name is Yong. I am a solutions architect at Orkes, and I live and breathe things like workflows, automations, and integrations. So I'm pretty full stack all the way from infrastructure all the way to front end. So I live and breathe everything in between. I've mostly worked in the finance space, so in fintechs, banking, sovereign wealth funds, so on and so forth. And you can talk to me about anything with all the other topics below once we're done with this. So what I've observed is a lot of times I go to events, I go to conferences, and I tell people that we are in the business of orchestration, and immediately they tell me, oh, it's Kubernetes. Right, and I'm like, no, because the word orchestration is actually quite general, right? in the grand scheme of things, it's about music. It's about the arrangement of things that harmonize, right? And this could be across a lot of different things. And infrastructure is just one of the things that you could do with it. And that is actually a pretty good use case that a lot of my customers actually use. But also beyond that, the abstraction also applies to different things. For example, you can do things like CI/CD pipelines. You can do things like application logic. You can serve synchronous kind of workflows. You can also do asynchronous kinds of workflows. So you can run anything from serving a web page that calls a service all the way to something that delivers like a canned report like every Sunday at 3 a.m. Right? So the breadth of what you can orchestrate is actually quite wide. And why that's the case is because the objective of orchestration is really to enable processes. And these processes could be anything that you can think of, right? It could be anything from running assembly lines on a factory floor, right? It could be process automation. It could be more specific into various areas like data, like security, like DevOps, like services, and increasingly AI as well. So all of these different kind of use cases all require different types of orchestration. And there are many ways that you can do that. And the problem, why this has become so problematic is also because the tech stack has increasingly become more and more and more challenging to manage. So we've gone from something very simple, from a single code base that runs as a monolith, to something that has so many different aspects to running a simple service. So today you have to deal with the front end, the back end, the API layer. You have to deal with streaming technology. You have to deal with Gen AI, increasingly the metadata around all of these things. You have containers, you have service meshes, you have all of these stuff as well. And orchestration can take place at any of these levels, right? Like we've heard from the previous speakers that it could be at the mesh level where infrastructure handles all of that. You could go one level higher in terms of abstraction and let a vendor like Rancher handle that as well. So at the application side of things, when you actually write all of your business processes, that could be a opportunity for orchestration to play a part too. Right. And generally speaking, if you look at the way people write code and manage all of their different microservices, typically it's like one of these like approaches that they take. Right. The most common approach is if you have like 10,000 different microservices that all do very, very specific granular things, and you want to create a business process that calls 5 of those services, what you do is you write the 10,001st service that actually calls all 5 services. So you end up with more and more and more and more services. And the problem with that is that it's very difficult to apply things like failure handling like universally. You could create a guide to tell people if you were in the business of calling these different services, this is how they behave, because they have different demands, they have different compute requirements, they have different ways in which they should fail. You should wait longer for that timeout because it takes longer to perform inference or whatever thing that's trying to do. But to get every developer to kind of do that in a uniform session is actually pretty difficult and challenging. So that's the first approach. The second approach, as event-driven kind of architectures have taken over the world, is to put everything on a service bus, right? So all our friends who do like the PubSub kind of mechanisms are very familiar with that. And then the last option is obviously with orchestration. So with yet another service, this is kind of what it'll look like, right? You have one guy who calls what we call gateway services, and these services do nothing but basically just call other services as well. And this is like the more primitive way that a lot of people are doing in order to like enable like end-to-end services. It's difficult to handle because failure handling is not consistent. That's the number one problem. And also because that whenever something fails in part of that process, it's quite hard to identify the point at which it failed, who failed, and how to remedy that situation, because you have to dig through logs and layers of logs. If you're tracing, good for you, but end of the day, you really need to get into the gist of like the entire flow to identify how failure happens and what you do when a failure occurs. And so things like idempotency becomes quite important if you're trying to rerun certain processes end to end to ensure that no duplication of any transactions happens. And so event-driven is the next kind of evolution to that, right? You have a bus, someone requests for something, it sends something down the bus, a service listens on it, picks it up, performs some kind of compute, sends another package down the bus, another service picks it up, and so on and so forth until the end of the transaction actually happens. So this is all great and good because now everything's decoupled, right? No one's like reliant on anyone. You can scale them independently. The problem with this is now when you're trying to recompose transactions, what do you do, right? How do you actually ensure that if I'm trying to rerun a transaction, the state of which is consistent with the point at which it failed? That's pretty challenging to do. And so to reconstruct these transactions is usually the pain point of why people try to avoid these kinds of event-driven architectures. And then onto orchestration, which is basically what we try to centralize the flow and maintenance of different things, meaning you decouple the definition away from the actual running of the execution. So while you have something, a template of sort in place to actually say, this is my workflow, you call service A, then service B, then service C, the actual execution of their workflow is actually decoupled away from the scheduling aspect of it. And that's how you can scale and manage these things in a fault-tolerant manner, and also enable them to be, again, scaled independently and as well as distributed across any cloud that you want to run it in, right? So what exactly is an orchestration in like general terms, right? So 3 different pillars, right? The first thing is we want to make complex flows easy. So if you're trying to write a very complicated business process and model it in a way that anyone, even a non-technical person, will be able to see and understand. The second aspect is to be able to handle failures consistently. So if there's something, a task that fails because of a certain outage of a third-party system or vendor or database or whatever, you want that failure to always be handled in the same way. If there's a retry policy applied, you always want it to be handled and done in that same way. And the third aspect is obviously if that policy fails eventually because there is a extended outage, you want to be able to very easily identify where the outage happens as well as recover based on any sort of intervention that you need to do, right? The next thing is also once you're in a state of modeling all your different processes into a way for you to execute consistently, you also have the opportunity to do modular transition, right? Mixing up basically human tasks, also with your API calls, also with the EI world. And so now your business processes can now have a mix of all of these different kinds of things, and you are able to actually run them in a seamless fashion from there. So enough talk, let's kind of like demonstrate what it actually looks like in real life. So what I'm going to do is show you the platform that we're going to use, which is called the Orkes Conductor platform. This is the same platform that was created at Netflix to run things like media encoding and interactive transcoding of all your different shows that you watch and games as well these days. So like as a kind of general primer for what a workflow looks like, when you kind of define a workflow, this would be pretty basic in terms of what a workflow is. So if I were to call a HTTP endpoint, I could run a fork to run things dynamically. I could add parallelism to it. I could add extra calls to it. And so without actually like being like a great developer of sorts, I'm able to just make use of pre-existing tasks that have been defined. I can do things like parallel runs. I can give it like a name, run it, save it. And once it's actually done, I can just run it seamlessly. And you can see that the execution actually like runs pretty quickly. You can look at timelines to like observe each and every task that has run. You can introspect every single run that has happened and look at the inputs that have gone into it, the outputs that have gone into it, and so on, right? You can also handle failure very consistently. So if I sabotage one of these endpoints to give it like a fake, why is my language not correct? But okay, that works as well. But if I save that, that will probably result in a DNS error. So if I run that, you can immediately see like where a failure has happened and what the failure actually is. And from this point in time, you can actually say, okay, because this is the failure that happened, I now have the opportunity to say, I only want to restart the entire flow, or I can say just restarting it from the failed task if all of these tasks that have run to completion are not designed with idempotency in mind, right? So you think about this and you'll be like, okay, so this is fairly like application level stuff, right? Why do I want to care about this as someone who thinks about infrastructure? But if you think about like the applications of infrastructure, that's also another way for you to apply something like a workflow engine to something that an infrastructure engineer would need to know, right? So case in point, what we actually do is we use our own software to deploy customer environments, right? So if I go and look at like this is our production environment. So yeah, that's the best place to try things these days. This is the entire workflow of like what it takes to deploy like a customer environment. And we run this like day in, day out, like multiple times a day. And so every time one of these things run, we actually like create a whole Kubernetes cluster. We create the whole like the Terraform steps are in there, the EKS, the CNI is initialized, the RDS is spun up. So all of these different things, all down to authentication, to ingress, to TLS, is all done using like a system like this. And we are able to like in real time observe all of the different inputs and outputs that go into all of these different tasks. And we are able to like troubleshoot whenever something fails. So it's not like a giant script, right? If you model everything as like an SH, if something fails, you have to go line by line to see, oh, this was the deployment that I did. This was the part that failed. Like if I have to troubleshoot from here on, I only need to take care of like step 7 onwards, which means I need to now manually try to fix that problem. But in our case, the retry mechanism just happens by itself. And so all of our customer deployments basically handle like seamlessly like retry. And the human intervention aspect is actually pretty minimal. So something like this can be applied just thinking about like spinning up environments or making changes to existing deployments as and when you need to scale deployments, like when demand shifts or when capacity is needed to like increase the number of compute that you grant to like certain projects and so on and so forth. So that's like one example of what like we do with that. Like another example could be something as simple as like if you think about like an application that someone's hosting. So let's like look at one that we have in insurance maybe. So you think about something is wrong with my language settings. I apologize for that. But if I go look at where is my insurance claim? So you all have insurance policies, right? I assume well covered. So imagine you're trying to make a claim for that. And so this is like an example of what the end-to-end process will look like. So like you feed like different things that go into that process. For example, like a policy number, a claim description, a customer ID, and maybe it goes into different endpoints to fetch customer data, fetch your policy details. It does a bit of matching in terms of what that happens, and then it goes to send you a notification in case that doesn't match. And then you can integrate it with an AI to say, okay, given this policy and given this person's claim description, should we like grant the approval for this particular claim, right? So you can pick any LLM provider that we can integrate with, any model that you wish to. And then once that AI bit completes, you can even like hook it up to a human for double verification, because we don't totally trust AI these days. And once that happens, you submit through a payment process that goes like end to end. So that's like a quick example of like what you can model with this. So if you think about like this being run as like the central process, all of your engineers would just be focused on building the individual microservices that perform the granular steps that are important to your business. So things like managing policies, making payments, sending notifications, whatever it is, right? And then all the plumbing you offset to like a platform like this that you don't really want to care about the boring parts of the business, but these are still critical things that need to run, and the reliability of these things are super important to running of your business as well. So this is how you should like allocate time spent in terms of like making sure you have good value for the time that you and your engineering teams have as well. Another interesting things that we have recently seen is kind of the rise of like private like databases. So if you look at like an indexing process, so for those of you familiar with like the AI bits of today, there's a lot of talk about this subject called RAG, or Retrieval Augmented Generation. And so RAG is a way for you to basically take content that you own. So it could be a private data set, so 500 pages of compliance or some customer service database or whatever, and all of those different things that you already own, index it into a way that an AI can actually pick up. And then when someone searches based on a natural language query, you basically pick up the data from that vector index and then feed it to a general purpose LLM that you don't have to like program from scratch. So just a regular like OpenAI GPT that you can take, and then that basically gives you the context to answer the question. And you don't have to rely on like model training that's incredibly expensive and requires any kind of capex. So that's another kind of example that we've kind of modeled within the workflow aspect as well. So if you just look at like conceptually what it does, it's actually not rocket science. Like anybody can do this. So like in the first task here, we're going to fetch like a book. This is a complete book from this website called Project Gutenberg. So we take the whole contents of that books, we clean up the data a bit, we chunk it, meaning we divide it into paragraphs, and then we add a bit more like the previous and next paragraph to it. Then we run it through a loop, right? For each loop, we'll grab a batch of those, so like 20 of those at one go. And then what we'll do is we'll send it into a dynamic index that will basically like take that the embeddings, throw it into what's called an embedding model, get the index data, send it into the index itself, and then we're done, right? And once we're done with that, the next thing we can do is actually run a search. So if you have a search engine, you can actually throw in like the query into your index itself, and then kind of rank it based on context, and then give you a response itself. So in this case, the example was using like storybook data. So then you could go into, sorry, I can't see my browser. Could go into a front end like this. Okay. Right. So imagine if this is like any kind of like data that you have, right? So in this case, I'm asking it questions about a storybook, and this could be a private corpus of data. So any kind of data that you want, and then you can have like someone answer, well, a bot in this case, answer questions regarding that. So you would think, you know, this could be like applied to any kind of data set that you have. And because most people think of like the response to this as non-deterministic, you actually can introspect every single flow that like gets executed there. So that particular flow that I just ran, you can just look at the inputs that went into there. You can see, oh, this was my query that I asked. It went into my two indexes. I can look at the inputs that went in there. I can look at the outputs that my vector database gave me. I can look at the transformation that happened, the re-ranking that happens. I can look at the actual LM interaction that has happened. So in this case, I'm asking, I believe it's, who was it? GPT-4o Mini by OpenAI, and then I'm just giving it the prompt, like given the context, answer that question. And then at the end of the day, this was the answer that OpenAI GPTs gave me, which got fed right up there. So this like basically gives you a quick understanding of the various use cases that you can apply of all the different applications of running something like an orchestration flow, all the way from infrastructure level to something like a backend process, all the way to something that's front-end driven. So yeah, that's kind of my talk. So thank you for attending, and yeah, happy to answer any questions that you may have. Yes. Yes. So Orkes Conductor is basically managed conductor. So under the hood is built on top of the open source Netflix conductor. Yeah. So today I've shown you the very, very simple stuff, which is almost like low code, but you can actually run like high code stuff. So you can actually run custom code that's being deployed in like a Kubernetes cluster in a private network. And we actually run like reverse like long polling, which means you don't actually have to open a hole in your firewall for the cloud hosted orchestration layer to actually reach your internal workers. So we do that so that you can distribute and deploy your workers and run custom code bases that interact with private systems. And that still allows remote invocation of that backend. Yeah, so that's the main difference. Yeah. Oh yeah, we support on-premise also if you want to. Yes. Yes. Any code. So we have SDKs in every language you can think of. So basically, if you already have a backend that does a very specific process, you inject the SDK, you say this block of code gives this name, you come into the orchestration layer, you create a task with the same name, then you can just basically inject a task within your workflow, which will be invoked whenever your backend runs. Did I see a question here? No. Okay. Yeah. 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 Right. So the idea is that there are a lot of these platforms out there, right? No shortage of it. There's Airflow, there is Vertex, there is all of these different things, and they're all very specific to a use case. So that one's more like the ML ops side of things. There are some that are very catered towards ETL. There's some very catered towards CI/CD and so on and so forth. So we don't participate in any of those areas. We try to be as agnostic as possible. So you can basically reuse like the same platform to do any given kind of application, and then use our RBAC model to basically segregate visibility between different teams. So that just saves you overhead in terms of administration. I'm actually writing a blog on it, so stay tuned. So we're trying to get up to as much as we want, basically. So in terms of our current customer base, like we start at around like 100 TPS, and we can scale up to like 2,000-3,000 TPS depending on like your workload. So it's all a matter of the infrastructure that you deploy to support that. And so because it's cloud hosted, we typically we work with customers on a single tenanted mod basis. So if they tell us their target TPS is 2,000, we'll deploy 2,000, we'll talk money later. But yeah, we can scale to any kind of number that you want, basically. And then if it's on-premise, we'll have guidelines for you to say, this is the kind of infrastructure that you need to deploy to support this level. And then they can just load test it themselves if they want it. Yeah. Cool. Okay. All right. Thanks everyone for your time. And yeah, I hope you had a great shift today.
Okay, can you guys see the screen? Okay.
Here we go.
Okay. So yeah, continuing, all the three speakers are done. Hope you have learned a few things today. These are our upcoming events in Australia, UK, and next event in Singapore is on 11th of December, here itself at AWS. There's a Kubernetes program. This is a program where a person can be called as Kubernetes once he completes all the certifications related to Kubernetes. There are 5 certificates: CKA, CKAD, CKS, KCNA, and KCSA. Once you are certified for all 5, you are considered as Kubernetes and you get a blue jacket. Okay. So how many Kubernetes are there? How many guys in Singapore who have already completed all 5 certificates and became a Kubernetes? 19 in Singapore. Globally, it is 800 to 50 in APAC, 10% in India. So yeah, we need to increase this trend, guys. Hurry up. Okay. Okay. So where you learn. So Code Cloud is one of the best option to learn. So here you'll find few of the offer codes for you to have subscription. Take a screenshot and you can utilize this offer codes. And also when you give these certifications, Kubernetes certifications, you have this 30% off code that you can utilize to reduce your certification cost. Take your time, take the screenshot, maybe you can use it. Okay. Okay, so yeah, this is the AWS Snort program. The person who completes all the 14 certificates from AWS becomes the AWS Snort. So just name, you get a golden jacket. Okay, you can join us. You can join this meetup. You can become a speaker, a volunteer, or a sponsor. Welcome. So you can scan these QR codes if you want to become a speaker. We are much appreciated if you be one of our speakers. Become a volunteer. Take your time. Okay. Yeah, you can follow us on LinkedIn, Twitter, and Telegram. These are the QR codes for it. Activate. Okay, you can give your inputs on this feedback. This is feedback form. Please provide us your feedback. What can we include? How can we modify this? What do you want to see in this particular meetup? Your feedback is valuable to us.
Yeah, guys.
Okay, there is some interruption, guys. Let's join us for group photo, and then we can conclude. Okay, please come on stage, and we'll have a group photo, and then we'll conclude. Thank you so much.